Friday we talked about different types of measurements. If you were to measure distance that you travel on a highway over in England, what would you measure that in? Kilometers. But if you were to measure it in the United States, you would measure in miles. So there's different types of measurement for distance. There's also different types of measurement for angles. And one is called degrees. The other one is called radians. And we talked about some conversion factors. If you want to take something and put it in degrees, you take theta, you multiply it by 180, and you divide it by pi. If you want to put something in radians, you take theta and multiply it by pi and divide it by 180. So, for those of you who weren't here, might be good to watch that video. It'll kind of give a better descriptor. What we're going to do right now is a very, very important day, okay, for us to kind of work through these pieces. We want to fill out some very important pieces on this circle. And I'm going to start with this spot right here. 0 degrees. If I were to go all the way around, how far around would that be? 360 degrees. Halfway would be? And as we fill this out, you really want to cognitively try to think through all these pieces. There's a lot of division, a lot of fractions that come up. The better you're able to work through that, the better off you'll be. How about this spot? How about down here? 270. Okay. Now I'm going to divide it up into smaller pieces. Okay? I'm going to divide it up into smaller pieces. For example, I'm going to take this 90-degree quadrant and I'm going to divide it in half. What would half of 90 degrees be? 45. That's fun. It's like pizza. How do you like to divide your pizza? Well, it depends on what size it is, right? If it's a medium, I like just cut it in half and I'm good to go, right? All right, so 45, 90, 135, 180. You got to add 45 each time, don't we? 25, 270, 315. All right, cool. Looks like we just divided the pizza up in eighths. Let's divide it up a little bit differently, okay? Let's divide it up into each 90. So divide it in half. Let's divide it into thirds. What's a third of 90? 30. Then the 90, then 180, 210, 270, 300, 300, 330. All right. Okay. So we live in the world of degrees. We want to be able to divide that up into radians. For those of you who weren't here on Friday, and even those of you who were, let me show you a really easy way to think about radian measurement. I'm going to start with a basic one right here. 180 degrees is the same as how many radians? Pi radians. So kind of like 2.2 kilograms is the same as, no, I'm sorry, 2.2 pounds is the same as 1 kilogram. 3.14 radians is the same as 180 degrees. Don't draw this, but I just again want to draw your mind and attention to it. If I draw 1 degree, it would be 1/360th of the circle, correct? Well, again, what we said is 1 radian is when the radius and the arc length have the same measurement. So when this arc length, we'll call it S, is the same as those two. Okay? That would be 1 radian. So a radian is somewhere between 55 and 60 degrees. It's actually 180 divided by pi. That's how many degrees a radian is. Okay? There's 3 of those, just over 3 of those things that fits in 180 degrees. But what we'd like to do is give really nice characteristics to some of these numbers up here. So 0 degrees is also 0 radians. A for the day, how many radians is 360 degrees? 2 of those, right? 2 of the 180s. Let's look at 90. How does 90 compare to 180? It's half. So 90 will not be pi, it will be pi divided by 2. Now, watch me count. This is 1 pi over 2, correct? 1 pi over 2, 2 pi over 2. So everybody see that those are the same? Okay, so 1 pi over 2, 2 pi over 2, 3 pi over 2. Again, watch me count. 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, which is the same as 2 pi. Is that nice? So we can count by fractions, no big deal. Oh, hey, let's count again. Let's go half of pi over 2. What's half of pi over 2? What's half of a half? A fourth. Hey, everybody, let's count. This is how you learn how to multiply, isn't it? Like my daughter, she's 5. She thinks she's really smart. She counts to 100, right? You know, right? She doesn't even know what sine and cosine are. All right, so she can count by ones. Good for her. Now I want her to count by tens. After she counts by tens, I want her to count by fives. After she counts by fives, I want her to count by twos. After she counts by twos, I want her to count by threes, then sevens, then fours, then eights, then sixes, and nines, right? And once she can count by those different numbers, not only does she know how to count, she knows how to multiply, right? So once we learn how to count, then we know how to multiply and divide. So let's count. 1 pi over 4. Are you making that connection? How many pi over 4s fit in the whole circle? 8. Yeah. 1, 2, 3, 4, 5, 6, 7, 8. Okay? All right. Let's try something else. Let's take this 180, instead of dividing it in half, let's divide it by 3. What's 1/3 of 180? What's 1/3 of 180? 60. Okay? So if we take this and divide it by 3, we get 60. So if we take this and divide it by 3, we get pi over 3. So now I'm going to count again. I'm going to move around my 60s. Pi over 3. So that's 1 pi over 3. 2 pi over 3. 3 pi over 3, 4 pi over 3, 5 pi over 3, 6 pi over 3 brings me back to 10 pi. Let's do it one last time. Instead of dividing up into thirds or fourths, let's divide. What's another number that divides evenly 180 really well? 6. Let's divide it into 6. What's 1/6 of 180? 30. So if 1/6 of 180 is 30, then 30 degrees is going to be pi over 6. 0 degrees, 1 pi over 6, 2 pi over 6, 3 pi over 6. And are you reducing these in your head to make sure that they work out? 3 pi over 6 is the same as pi over 2. See that? So when the number is written, it already reduces. 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6. After 5 pi over 6, 6 pi over 6, 7 pi over 6, 8 pi over 6, 9 pi over 6, 10 pi over 6, 11 pi over 6. These conversions you should know well, and you should know them quickly. And in fact, we're going to play a little game, okay? Ooh, you need a partner, okay? So let's go, we'll go just like this, okay? We'll go you two, okay? Faith and Juliana, you guys can go. Emma, why don't you come up here and join these two right up here. You two can go. You two can go. Brock, you and Coy, and then you two, okay? Now, I'll show you what you're going to do, okay? All right? These are the keys. Once you know these, you can figure out all the rest. Now, I'll do an example, okay? I'll do it the hard way, and then I'll do it the easy way. On Friday, you learned if you want to take 240 degrees and turn it into radians, really there's 3 ways. Number 1, you can look at your sheet and cheat, right? You don't get that on the test. So if you want to convert this, we said you can multiply by pi and divide by 180. So let's look at how we did that. What do you cancel off? The zeros. So you have 24 pi divided by 18. What number divides evenly at 24 and 18? 6, so that would be 4 pi over 3. Finally, I'm done, right? That's the long way. When I show you the easy way. He always like, yes, please, I want easier, right? We all want something easier, right? Let's show the easy way. Can somebody tell me which one of these, which is the biggest one that divides evenly into 240? 60. 60. How many times does it go in? 4. You see that? You want another one? What's this? 330. Which is the biggest one here divides evenly into 330? 30. How many times does 30 go in? 11 pi over 6. You see it? Which one goes into 150? 30. How many times does 30 go in? 5. Watch. This one's tougher, isn't it? Now it's got a 5 on it, so which one do you think is probably the deal? Yeah, you're right. You're thinking, okay, probably 45. If you just think about it, 135 is there, right? So I'm just going to count. 1, 2, 3. Because 45 is half, right? 3. 3 5 over 4. You think you could try it? You're going to face off against your group of 2 or 3. And here's what your... yeah. All right, so here's what I'm going to have you do. You're going to have some scratch paper somewhere, okay? Any type of scratch paper. You could just write down an answer really quick. And you're going to compare it to your friend. I'm going to give you 9, and I'm going to write 1 down, and you want to try to convert it before your friend does. Now, you just keep track of how many you win, okay? There's no prize here. Just want a little friendly competition. No trash talking, Ashley. Okay? There's no I and win. Yeah, there is. Okay, but you want to try and come up with it as quick as you can. All right? You guys ready? Try to do the trick just like I did. I'll leave these up here so you can see them. Start with the first one. 300. You want to write it down before your friends do and see who got it. And stop. Okay? No, you don't. No, you don't. Because I'm going to show you that you don't need it. Okay? You really got 2 options here. What's the biggest number that divides evenly into 300 that's up there? 60. And how many times does it go in? 5. Now, did you choose 30? Okay, and that's fine. But then look what you have. 30 goes in how many times? So then you got to reduce it to 5 pi over 3. Close counts and horseshoes and hand grenades. Okay, number 2. All right, so keep track of, you guys might have to do first, second, third. Kind of see. It's okay. It's all right. We want to try to be quick at this because you guys, we're gonna do problems in a little while, and I'm gonna write, I'm gonna write 60 degrees, and you gotta make that conversion. And I don't want to sit in class for a minute and a half trying to tell you how I came up with pi over 3. I mean, we want to know these, okay? So, do you have to memorize vocabulary for Spanish class? Yeah, you do, don't you? So this is kind of like our memorization, but there's a nice little process, okay? So, you ready for another one? Here we go. 120. And you should have pi over 3. It goes in twice. Okay? Here's another one. Ready? 150. And stop. You should grab 30. It would be 5 pi over 6. more. Here's another one. 180. Yeah, all right. Okay, you got it. Yeah. Did anybody write down 2 pi over 2? Yeah, it's pi, right? It's pi, right? Okay, good. All right. We're having fun. We'll try again. Ready? 240. Okay, 4 to the 60, so 4 pi over 3. We're going to give you a tougher one. Give you a tough one. Are you ready? This is a tough one. 225. You know it's 45, right? So count. Were you able to locate that 225 is going to be right there? So you know it's 45, right? So it's 1, 2, 3, 4, 5. It's 5 of the pi over 4s. That's how I'm just trying to describe to you guys how I do it, okay? So I don't want us to have to punch in the fraction button on our calculator every single time. I want us to try and be quick with it. Here's another one. Another tough one. 135. How many of the pi over 4s? 3 of them. Okay, 2 more. I like this one. Go big or go home. 270. And choose 90, right? How many times does 90 go in? 3. Yep. 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 Half a point off on the test. Yep. You have to have your fractions reduced in simplest form. Well, not like this. No. Well, I'm put a little pressure. It's an edgy class. All right, number 9. All right, we're gonna try another one. Here we go. 330. Oh, why don't you tell us how you really feel? I actually think that's a pretty nice one. It's got the 30 right in there, and it goes in 11 times, so it's actually a pretty nice problem. So, wait, not you like kind of the shortcut idea? Because I mean, if you sit there, just think about it, folks. If you say, okay, every time I see 330, I'm gonna multiply it by pi, divide it by 180. Let's see, those cancel. Then I'll divide by 3, and now I get 11 pi over 6. That takes a while, doesn't it? If you could think of it instead about multiples of these pieces that we just simply counted through, then hopefully that goes a little bit better. Okay? Hopefully it goes a little bit better. Tell you what, how about we do this? You want no assignment tonight? Okay, then we're going to go right up to the bell with this, but we'll have no assignment tonight. We got to do a slight review of special right triangles using some geometry ideas, okay? So, um, this is a little bit of review for you, but there were some special right triangles that you guys talked about back in geometry. Isosceles is a type of triangle, so is scalene, okay, so is equilateral. But these ones are special right triangles because of angles. The first one I'm going to talk about is 30 degrees, 60 degrees, 90 degrees. Now, all of these will have a right angle because that they're right triangles. Now, we do two examples here, okay? We do two examples. I'll do one in green. I'll do another one in blue. Suppose this has a length of 4. I want to be able to figure out the other two sides. A 60, 30, 90 is half of what kind of triangle? It's half of an equilateral. And what do you know about an equilateral triangle? All the sides are the same. So if this side is 4, what is this smallest side going to be then? Because it's exactly half, isn't it? Do you remember what you do to the small side of a 30, 60, 90 triangle to get the hypotenuse? Yes, we'll do that in a second. But do you remember how to go from here to here? This is always, we'd always take this and multiply by 2. Do you remember how to go from here to here? You multiply by the square root of 3. Do you remember that? Okay, then let me show you why that works out, okay? Let me show you why that works out. This is something you talked about in geometry, but this is why we're reviewing it, and that's why this lesson takes a little bit longer. If I call that side B, I would say 2 squared plus B squared is equal to 4 squared. So 4 plus B squared is equal to 16. Subtract the 4, and you get B squared is equal to 12. Square root both sides. B is equal to the square root of 12. Hey, what's a perfect square that you can take out of 12? 4. So you would get 2 roots of 3, correct? Look at that. It's that side multiplied by the root of 3. All the time. Do another example in blue, like I said. Suppose this side is 5. Then what would the hypotenuse be? 10. What would the long leg be? 5 roots of 3. Hypotenuse is always double the shortest side. Let's switch it up a little bit. Instead of a 30, 60, 90, let's do a 60, 30, 90. Which is really the same thing. Suppose we know that this side is 4 roots of 3. Can anybody tell me what the short leg is going to be? 4. And what would the hypotenuse be? 8. I'm going to switch it up. Suppose the short side was 2/5. What would the hypotenuse be? 4/5. What would the long leg be? 2 roots of 3 over 5. Does it come back just a little bit? Okay, then we do one more, and we're done for the day. This is a 45, 45, 90. Can somebody tell me what we know is for sure true about a 45, 45, 90? Very good. The two shorter sides are the same. So if this is 8, what is the other side? 8. And what would the hypotenuse be? This one you don't multiply by the root of 3. You multiply by a different square root. Yep, 2. 8 roots of 2. So if this is 5, what would this side be? And what would this side be? All right, do one more. Try to catch you here. What if that side is 7? Instead of multiplying by the root of 2, I would divide by the root of 2. And are you allowed to have a square root in the denominator? So I multiply top and bottom by root of 2, and I get 7 roots of 2 over 2. So 7 roots of 2 over 2. So I just wanted to try to show you 3 examples, because tomorrow what we have to do is we have to do what this is really the first chief content on your final exam for quarter 3. And that is you have to be able to identify terminal points. Okay? And we'll talk about what that looks like. And it will start by converting from degrees to radians, and then we'll be making special triangles. So we will do 4 examples in class tomorrow, and then you will be given a lot of time. But folks, raise your right hand. Repeat after me. I do solemnly swear that if I am confused at all tomorrow, I will ask questions. And if I do not, Mr. Yentz has permission to pull my toenails out with a needle nose pliers. Okay. All right. Very good. All right. I got you. All right.